In Chapter 2.3, we're going to continue our discussion of how to build graphs that give visual representation to our data. In Section 2.3, though, we're going to focus more on how to represent our data from a categorical perspective, taking a look at our data in categories and comparing them to one another, rather than more of a quantitative perspective where you see the actual values represented. Here again, these graphs are gonna represent things more from a categorical perspective. Okay, the first graph that we're going to take a look at is called a bar graph. It represents the data by using vertical or horizontal bars whose heights or lengths represent the frequency of the data. Let's take a look at our first example. The table shows the average money spent by first-year college students. Draw a horizontal and vertical bar graph for the data. So here's how we approach this. Notice that when it says up here representing the frequencies of the data, it's not 100% accurate with what we have been looking at when it comes to frequencies. Because in this context, what do we have? I don't have classes with defined class widths of lower class limit, upper class limit, boundaries. I have a category. I have a category of electronics, and on average, first-year college students spend $728 on electronics. And then the next category of dorm decor, and then clothing and shoes, and the corresponding values that they spend on those different categories. The goal here is to represent this visually. So we will do both of these, horizontal and vertical. Let's do horizontal first. Actually, I take that back. We're going to do vertical first. So how do we represent a vertical bar graph for these categories? Well, what we're going to do is on our horizontal asymptote, we are going to place those four categories. We're going to do electronics, decor, we're going to do clothing, and we're going to do shoes. Okay? So we have on our horizontal axis each of our categories listed out. On the vertical axis, what I'm going to do is I'm going to take a look at the units for whatever measurement is taken in each of those categories, and I see I have a minimum of 72 and a maximum of 728. You always want to start at 0 here. So I'm going to go 0 up to, I'm going to go 800, just a little bit above. I'm going to count by hundreds. So we're going to go 100, 200, 300, 400, 500, 600, 700, and 800. Now what I'm going to do is, let me put dollars. Let me label that. Okay, so for electronics, I am going to draw a bar that goes all the way up to 728. Now I'm looking at decor. I'm going to draw a bar that goes up to 344. It's about right there. For clothing, I'm going to draw a bar up to 141. And then shoes, I'm going to draw a bar up to 72. So a couple things to notice. Each bar has the same width as all the other bars. Also, there's a gap between each bar. Unlike a histogram that we looked at in the previous unit, where all the bars were put together, right, because each class built on the other class, it was a continuation from the upper limit being the new lower limit. Here, that's not the case. We just have 4 different categories here. Okay? And so the spacing is important to show that it's categorically presented. Okay? Now, we could recreate this thing using horizontal bars instead of vertical. All we would do is switch the axes. Electronics, decor, clothing, and shoes. I'm going to go 100, 200, 300, 400, 500, 600, 700, and 800. Oop, I wrote 1,000 there. And then for electronics, Again, I'm coming all the way out to 728. For decor, I'm coming out to 344. For clothing, I'm coming out to 144. And for shoes, I'm coming out to a 72. Again, the widths and the distances between the bars are all the same, but I can represent it either vertically or horizontally. So there's a bar chart or a bar graph. The next one we want to look at is this thing called a Pareto chart. Very similar to a bar chart, except there's two differences here. So a Pareto chart is used to represent a frequency distribution for a categorical variable, and the frequencies are displayed by the heights of vertical bars. So we're only going to be doing vertical, which are arranged, here's the key, in order from highest to lowest. So what we're going to do here is we're going to do a bar chart, except we're going to use vertical bars only and arrange in order from largest to greatest. If I look at that, here's my largest. I'm going to say just 1, and then 2, 3, 4, and 5. I think that's the ordering right there. So I'm going to go DC, and then I'm going to go New York. I'm going to put these a little closer together. You'll see why here in a second. New York, and then I'm going to go Boston, and then I'm going to go Chicago, and then I'm going to go Atlanta. Let's see, my highest value is 82, so we'll count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. So in DC, I'm up at 82. So that's up here. I'm going to draw that. And then at New York, I'm at 74. That's about right here. You can already see one difference. I'm actually putting them side by side. I'm squishing them together so there's no gap between the bars. For Boston, I'm up at 64. It's about right here. Chicago, I'm at 61. And Atlanta, I'm at 52. So again, I'm only using vertical with a Pareto chart. I'm squishing the bars together using the same width for each bar, and I'm arranging it from the highest to the lowest value. That way it gives me a chance to compare them without having fairly easily from a largest to smallest, or rather smallest to largest perspective if I look backwards. Great. So a Pareto chart, similar to a bar chart, except we only use vertical and we arrange it from highest to lowest. The next chart we're going to take a look at is a time series chart. And like it says, you can probably guess, we're going to be taking a look at things in terms of time. We want to see how something changes over time. So we have some data here. The data show the average cost of a 30-second television ad on the Academy Awards show. Draw and analyze a time series graph for the data. Okay, so a time series graph, instead of using bars, we're going to use points. So we're still going to have our vertical and horizontal, and the horizontal axis is always the time axis. So we're going to do year. The vertical axis is whatever our frequency is, or whatever the value is at that specific time. For us, it's cost. And it looks like in millions. Okay. Now I'm going from 1.4 up to 1.9 million. So I'm actually going to count by, I think I'm going to count by 0.02s. So 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0. And then along the horizontal axis, okay, I'm going to put my years. I'm going to say 2010, 2011, 2012, 2013, 2014, and 2015. Now keep in mind, let's say this one didn't exist. I would still have to have 2014 here because I need equal division between my time units. And so keep that in mind. Now, I'm just going to plot these points. In 2010, it was at 1.4. 2011, 1.55. 2012, 1.61. 2013, 1.65. Then 1.78 in 2014 and 2015, 1.9. And then I'm simply going to connect each of these dots. So what is a time series graph? It shows us the change in a specific variable over time. The variable here being the cost of a 30-second television ad on the Academy Awards show. Good. Well, a couple more to look at. Let's take a look at what is called a pie graph or pie chart, is another way that you may have heard this phrased. This is an opportunity for us to geometrically look at the relationship between each category in reference to a whole. Here's what we mean by that. This frequency distribution shows the number of pounds of each snack food eaten during the Super Bowl. Construct a pie chart. So, potato chips, 11.2 million pounds. Tortilla chips, 8.2 million pounds. Pretzels, popcorn, snacks, for a total of 30 million pounds. With a pie graph, here's what I want to do. I want to find out each of these frequencies as a percentage of the whole. So what is 11.2 million as a percentage? So 11.2 million as a percentage of our 30 million. Well, if I take and I do my 11.2 million divided by my 30 million, I end up with 0.37. Now, if I convert this from a decimal into percentage, that's 37.3%. So 37.3% of the snacks eaten, out of the 30 million pounds of snacks eaten, belong to the potato chip category. If I were to do the same thing with each of these, I would end up with 27.3%, 14.3%, 12.7%, and 8.3% respectively. Again, just doing the division that I did from that first category of potato chips. So what we want to do now with that is we want to create a pie chart. So we draw a circle with a point at the center. This circle, if I look at this circle and I say all the way around represents 100%, right? Which means if I cut it in half, each half represents 50%, right? If I cut it in half again, we would say that each of these represents 25%, okay? But I want to actually break it down to where each portion of my pie chart represents those percentages. Now what I'm going to do is I'm going to pick an arbitrary spot to start. I often pick just a horizontal to the right. I'm going to start with 37.3. Now I know if I rotate a quarter of the way around, I'm at 25%. If I rotate another quarter of the way around, I'm at 50%. Well, 37.3 is pretty close to halfway between 25 and 50%. So I'm going to draw my next line about right here. And I'm going to, in here, write potato chips and 37.3. Good. Now, from this line, I'm going to use my next one, tortilla chips, 27.3. Well, I know if I go a quarter of a way around, which from here to here is about a quarter of the way around, if I go just a little bit more, that's 25%. So a little bit more gets me to the 27.3%. Okay, so in here, I'm going to draw or write tortilla chips. And this is 8.2%. I'm sorry, 27.3%. Now from this line, I'm going to do my 14.3%. Well, again, I know that if I go a quarter of a way around, that's 25. So 14% is going to be about right here. Okay. And interesting, 14% and 12% is about 26, with the decimals 27. So this line is actually really close to where I need to have that other line be. So in here is my 14.3%. Here is my 12.7%. And then the remainder is my 8.3%. And each of these being pretzels, popcorn, and snack nuts. So here is our pie chart. It takes a whole circle and says the whole represents 100% of everything. And it takes each category and sections it out into a pie chunk that represents how much out of the 100% belongs to each of these categories from a percentage standpoint. So there's pie charts. We've got two more charts that are a little less common. This first one, dot plot, is a pretty straightforward chart to use. Okay? So we've got data here that show the number of named storms each year for the last 40 years. Okay? A dot plot simply takes and graphs, it's a statistical graph in which each data value is plotted as a point above a horizontal axis. So all I'm going to do for this is I'm going to draw a horizontal axis. Okay? And let me make that a little more horizontal. And what I'm going to do is I'm going to take a look and let's see, my smallest value here, it looks like is the 4 right here. My largest value, I think, is this 28 over here. So on my number line, all I'm going to do is I'm going to make dashes. Okay, from, I'm going to start at 0 because 4 is pretty close to 0. 1, 2, 3, 4. 1, 2, 3, 4, 5. And I'm going to go all the way up to 30. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Whoa. Need to extend that a little further. 26, 27, 28, 29, and 30. And all I'm going to do is, for every data value that I have here, I'm going to put a point above this number line. So I see 19. I'm going to put a dot. I'll just go down each column. So I'm going to go 9, 16, 15, 10, 28. Now my next column, 15. Oh, I already have one at 15, so I'm just going to put a point right on top of that. 16, again, I got a point on top of that already there, so I'm going to put a point on top of that. I've got 12. 15 now has 3. Oh, 15 has 4, and then a 12 again. Now I'm on my third column. I'm going to go 14. Let's see, 8, 13, 19 gets the second one, 7, 8 gets a second one. Now I'm on my fourth column, 7 gets a second one, 8, 14, 11, 12, 7. On my fifth column here, we're going to go 6, 11, 13, 4, 6, 12. Now the next column, oh, I think I just put that at 11. So let me erase that. I'm going to go 12. Now I've got another 11, a 9, a 12, a 6, a 10. Move this one down just a touch. So a 10 and a 9. And then I've got another 11. I've got an 8. I've got a 7. And I've got a 13. And there we go. That is our dot plot. Now, a couple things. The number 6 I'm going to redo a little bit because those 3 dots looked like the same height as 4 dots, and I don't want it to. I want to make sure my dots are lining up nicely so that each of these numbers along the number line, the height of the dots is reflective of the frequency that value occurs. And in a lot of ways, this kind of turns into a bar chart of sorts, but instead of bars, I have dots. So that's a dot plot. Last but not least is one of the more obscure but extremely useful plots, the stem and leaf plot. Stem and leaf plot is a data plot that uses part of the data value as the stem and part of the data value as the leaf to form groups or classes. So what do we have here? It says this: at an outpatient testing center, the number of cardiograms performed each day for 20 days is shown. So on the first day, 25 were performed, then 14, then 36, then 32, then 31, and so on and so forth. It says construct a stem and leaf plot for this data. With a stem and leaf plot, here's what we always want to do. We always want to start by arranging our data in order from smallest to greatest. So that's what's been done right here for us. The smallest value is 2. And I also want you to notice here, all my data values here are 2 digits. 2 is actually only 1 digit, but look what we did. We added a 0 in front of the 2 so that it had the same number of digits as everything else. 0, 2 is the same thing as just 2. You'll see why that's important here in a minute. What we're going to do is this. Now that they're in order, we are going to take and create a stem and a leaf. The left-hand side of my chart right here is my stem. Over here is my leaf. And here's what I notice. I have a group of numbers that start with a 0. I also have a group of numbers that start with a 1 in the tens place. I also have a group of numbers that start with 2 in the tens place. I've got a group of numbers that start with 3 in the tens place, and then likewise 4 in the tens place and 5 in the tens place. I'm going to let the tenths place be my stem. So I'm going to go 0, 1, 2, 3, 4, and 5. Okay, with those stems established, here's what we're going to do next. What are all the values that have a stem of 0? Well, it's just this one right here. So the tenths place is my stem. The ones place is my leaf. I'm just going to go ahead and write a 2 right here. So one of my data points is 0, 2. Let's take a look at our next stem of 1. I have 2 values that fit in that stem. I have a 1, 3 and a 1, 4. Notice what I'm doing is they both share the stem of 1 in the tenths place, but then one of them has a 3, the other has a 4. You can start seeing this already, that if there's more values in one of the given classes or groups of the stem that we have, it's going to create a list of numbers that is longer. Okay. Now let's look at the stem of 2. I've got 20, 23, and 25. Now let's look at the stem of 3. I've got 31, I've got 32, I've got another 32, so I'm going to put another 2, another 32, so I'm going to put another 2, another 32, so I'm going to put another 2, then I have a 33 and a 36. So again, this represents 31, 32, 32, 32, 32, 33, and 36. Now we move on to the 4. I've got a 43, a 44, a 44, and a 45. Notice I'm lining everything up nicely so that all the lengths of the leaf are relative to each other with the frequency that they occur. And last but not least, the 5, I've got a 51, I've got a 52, and I've got a 57. This is a stem and leaf plot. And one of the things I always like to kind of view this as, it's a way of doing a quick visualization of really a histogram. If I let each of these stacks of numbers define the length of a bar, I essentially have a histogram laying on its side. And the bar length shows the frequency relative to the rest. Those bars aren't necessary, nor are they ever put on a stem and leaf plot. I just like to visualize them for what the stem and leaf plot accomplishes for us. But there we go. There's our stem and leaf plot, final plot that we want to take a look at in section 2.3 to do visual representations of what our data looks like.